All right, hello grade 8s, and we are on to lesson 1.2, prime factorization. All right, and it's found on page 8 of your textbooks. Okay, so what you want to do is start taking notes, and at the beginning of your notes, write this, write that, and you can follow along on page 8 in your textbook if you want. Goal as set out by the Nelson math book is to express a composite number as a product of prime factors. All right, so let's go through this and you will be way more clear on it once I'm done. It's a relatively short one, okay, pretty much one concept, and then we will go over the rest of this tomorrow. So take good notes and we'll see how this goes between the two of us, all right? Or me and 50 of you around there. Anyway, so let's continue. All right, so definition. The prime factorization is, according to Nelson, the representation of a composite number as the product of its prime factors. Essentially what you want to do, in plain speak, is you want to multiply or divide your numbers down to prime factors, whereas you cannot divide anymore. And remember, what's a prime factor? Two factors, one and itself. Okay, so once you multiply the number down, divide the number as far as you can go, and it stops at a prime number. So for example here, all right, and I will explain more, I'll explain more tomorrow. So let's take a look here. 24, prime factorization. It works out to 2 times 2 times 2 times 3, or 2 to the power of 3 times 3. Now, what does this all mean? How did I get this? Let's go through an example, okay? It's very simple stuff. Just maybe this is a little more difficult than it needs to be. So again, we'll go through this and we'll work together on a lot of this, so don't you worry about it. But take good notes right now and come in prepared. So let's take a look at here, okay? So remember, continue to calculate factors until only prime factors are left at the ends of the branches. Okay, so we're going to use a factor tree. Okay, so our number is 1050 or 1050, and for your old folks, 1050 used to be a very classic AM radio station in the city of Toronto. So let's take a look here. So we have, let's go use purple today. All right, so 1050. Let's take some numbers that are easy to work with. 10 and 105. So 10, okay, 10 times 105 will give you 1050. Now I'm not done yet. This is a prime factor? No, it's not. There are several factors that can make 10. 1 times 10, 2 times 5. Okay, so let's go here. Okay, 2 times 5. There's your factor tree right there. Now, this, can you go any more than 2? Can you factor that down? No, you can't. Okay, the only factors here are 1 and 2, and that's it. Okay, same with 5. You can't do anything other than 1 and 5. 5, 2 prime factors. All right, let's continue here on 105. So 5 times, okay, so 5 times 21 will give you 105. Now, this is all pre-done. Okay, there's no trial and error here. I've already worked it out ahead of time to make it easier for you. I'll go through this tomorrow with you, or next day, and I'll explain how we went through this. Okay, now 21 is not a prime factor, still a composite factor. Okay, composite number, sorry. Okay, now how can I make 21 in a numerical term? Well, easy right here. Okay, 7 times 3 gives you 21. All right, so now what I have here, I'm going to change the color here. All right, what I have here are the numbers. These are the numbers that I will be using as the prime factorization. All right, now we take the numbers and we list them in order, least to greatest. So 2. So 105, 1050 equals 2 times 3 times 5 times 5 times 7. Now, I'm not done yet. And as we saw in the previous example, let's go back here. Notice we saw an exponent, which represented 2 times 2 times 2. Okay, we're going to use the same example here. We're going to use the same formula, same operation. Okay, so 2, this continues. Okay, we're not done there. So 1050, 1050 equals 2. Prime factorization. 2 times 3 times, now there's 2 of these, 5 times 5, 5 squared times 7. Okay, that is 1050 represented in prime factorization. Okay, so again, we'll go over this tomorrow. This is a really short one, and I don't have a question for you today, so we'll talk about this tomorrow. Take good notes, take this example down, go back and take good notes, pause whenever you want, and stop it if you're not understanding something. Go back over it, and again, tomorrow let's open the questions and we work on it together. Okay, so that's what we got so far. Hope you like this one, and we'll see you soon. Bye bye.